Today is July 24th, 2025. This is Newman, and I am here with Harsha and Code Cow Unspent and Lewis and our new friend Jason. Thanks for tuning in. This is the Community Code Review, the Datum Dawns, presented by Gimbalabs, where we explore Aiken Validator code together, line by line, question by question. Let's get into it. Who is the Dawn and who are the capos, and what Aiken Validator are we reviewing? Who is the Dawn?
So I will be the Don today. Um,
All right.
and we have four capos, which is great.
Beautiful. And
Um,
which validator are we going?
so we will be doing stake validator, which is a pattern from Anastasia Labs. This is a pattern that is used when you are spending something and there is some withdrawal function in the spending. Uh, so it is a way to minimize the compute of that specific validator.
Okay.
Are we ready to go?
Yes, sir.
Okay, so I'm just going to read this. So it says these are helper, this is a helper function for implementing validation for specific UTXOs, essentially delegating their requirements to the given withdrawal validator. In simple terms, it says as long as there is a rewards withdrawal involved, a rewards withdrawal of the given script in transaction, this UTXO can be spent. As long as there is a rewards withdrawal of the given script in transaction. Okay, so as long as there is a withdrawal somewhere in the transaction, so we can use this script. Okay. Allows you to validate based on both withdrawals redeemer, mostly useful for ensuring specific endpoints are invoked, and the withdrawal Lovelace count. Okay, so this is still a bit confusing for me, even though
Yeah.
I kind of went through before. Uh,
Yeah.
but we'll start and see where we can go. So they are defining
Yeah.
a function, which is the spend endpoint basically, and it takes three parameters, which is the withdraw script hash, which is just the hash of the script, withdrawal script. And then it takes a function that has two parameters. One is the redeemer, and the other one is the amount of Lovelace, and it gives a bool. And the last one is the transaction. So these are the high level, these are the base spend script purpose parameters that they are giving in for this function. And this function, again, as usual, gives out a bool. And what they are doing initially is they are destructuring the transactions to get the redeemers field and the withdrawals field from the transaction. As you remember, transaction object has the redeemers field and the withdrawals field. Let's quickly take a look at what those fields
Yeah, that
look
might be a good
like.
one. Yeah, transaction. Yeah. Yeah.
So the withdrawal field is pairs. So when you see pairs, it is basically a list of pairs. Uh, so this pair, each pair has a credential, which can be a pub key credential or a script credential, and the Lovelace involved. So because and this Lovelace is the amount you're withdrawing. Okay. And the redeemers is a list of pairs where the first part of the pair is a script purpose and the associated redeemer for that script purpose. So both of them are pairs. Okay, so now we understand that. Let's see what the next step is. So the next step is they are creating a variable called withdraw script, which is so it is this. So they're creating the script from the withdraw script hash, and withdraw script hash is one of the parameters in the spend function. So
Okay.
so when you have that hash, you can actually create the script. So let's take a look at that as well.
Yeah, why would we not just compare the hashes? What does this function do?
That's because of the reason we don't directly compare the hashes is because the withdraw has the credential, and it, oh, wait a minute. Oh, what? Yeah, it has the credential. It doesn't directly have the hash, right? No, credential is a hash. What am I talking about? So I'm guessing it's probably because they need the script purpose. Let's take a look. Let's take a
Well, let's look at
look.
the function. What does it do? What is
Yeah,
when you do equals capital script and you pass in the withdraw
yeah,
script hash? What does that output?
yeah. So a script is a byte array.
That's the type.
Uh, what is this script? Yeah, what is the script doing? Maybe we should look at um
It comes from
uh,
Cardano address.
so if we look at address, and maybe it's a part of credential. Oh, here it is. So it creates the credential for the script. So it
It
takes
creates it.
the constructor script and takes in the script hash and creates the credential. This is very similar to creating like a credential from a verification key hash.
Yeah.
Okay, so we are getting the script credential. Okay. So we are getting the script credential here and storing it in withdraw script variable. And then we are creating another variable called withdraw purpose with the withdraw constructor. Let's take a look at that. Uh, script purpose. Script purpose. So it takes the withdraw constructor and the credential and it gives out the script purpose
So that's why we need to get the credential into the
into
in
the
there.
withdraw constructor. Yeah.
Yeah.
So, okay. So, okay, got it. So that is why this is called the withdraw purpose because it is creating the withdraw purpose here. Okay.
So it's just weird that they wouldn't call that withdraw credential. If withdraw function needs a credential, why are they calling it the script? But doesn't
I
matter.
mean, we can just call it withdraw script credential to be fair, which would be better to read.
Yeah, I'm just trying
Naming.
to learn, right?
Yep. Yeah. Naming things. Always the thing. When you
Yeah,
read someone else's code, figuring out their idea. And this is a different, these are the Anastasia. This is not,
yeah,
we're not in the happy zone of Henson and Aiken, anymore. So this is good. This is good. Um,
hence it
all
does
right.
take like extra time to make things easy to read.
Yep, yep.
Yeah,
I guess what I'm saying is it's a relative thing. So it maybe, it's just sort of like, you have to figure out what the other person was meaning. And that's why we go through a community code review. So we all like, oh, right. And learn it
yeah,
together.
definitely.
Yeah. So now we have the withdraw purpose and we are creating a new variable called withdraw redeemer, which is of the type redeemer. And to get that value, we are piping in the redeemer into pairs.get first. Let's quickly look at get first. I mean, it pretty much says what it is,
Yeah,
but
pretty simple, but yeah, good worth checking out the
uh,
docs.
so it takes in like a pair and it takes in a key and it gives an optional value. Okay. Uh, so tell me one thing, guys. So does it matter if so, for example, this get first is a function that takes two parameters, right? Does it matter which parameters goes first and second? Because
Yeah,
I see here that like the redeemer is being piped in, so I'm assuming redeemer is the first parameter.
yeah.
But here, oh yeah, that's right. Redeemer has to be the first parameter because it's the pair. Because and so the redeemer. is a pair with the script purpose as the first parameter and the redeemer as the second parameter. Okay, so it's a whole pair, by the way. Okay, that makes sense. The whole pair goes in, and then the withdraw script purpose is the key, right?
Yeah, that
Is
makes
it the
sense.
key? Yeah, script purpose is the key, and then you get the associated redeemer for it. Okay. So you get like an optional redeemer right here, and they're enforcing a type. So tell me one thing, when you say let withdraw and like enforce a type here, and say for example this gives a different type, will this line fail?
Yes.
I
And where would it fail? I would
Right
assume it
here.
would
not
fail, but
expecting.
that's true. Well, okay. This gets to another question I had from earlier, but I'll go. I'll let. My question is this a validator? Because it doesn't use the
No.
validator keyword. It just has the function. It's just a function.
So
Yeah,
script,
just a function returning a bool.
Yeah.
so isn't script purpose also a function? Like when you say some validator and then you say is, spend and then you start the whole thing, like isn't that also a function?
I think everything's a function.
Yeah.
Yeah. It's just they're special, right?
A
That's why
validator
we
special.
it's like
Yeah.
a special function. Yeah. Yeah.
Yeah.
So, right, I think it, my guess is it wouldn't, I don't know. Probably would throw an error somewhere, right? If it was typed wrong, it's
I
going
mean,
to say,
I
I
mean, we
expect
wanted to
this.
throw an error if it doesn't match, right? So I'm
Yeah,
assuming
I think it
this
would.
should fail if it doesn't match. And also one other question I have is why are they saying get first? What if there are multiple withdraw? So they're assuming there is only one withdraw
Oh,
and they're
I
not multiple
think there
withdraws.
can only be one. That's what that diagram was looking at. You can have multiple UTXOs, but per transaction, there's only one withdraw script. I don't know. That may be wrong because it's a pair.
yeah. I think it matches the first one, which has the key the same as the withdraw purpose. So I think since the redeemers is a list of pairs, and then so you want to you don't want to do a lot of computation. So if you get the first match, you just get that one. You don't keep
Oh,
doing
it
the
is
computation.
doing the first match. Oh,
Yeah,
I
I
see,
think
I see, I
so.
see.
Yeah.
I thought it is just taking the first pair and checking if that key is existing in it. Okay, okay. So it's just,
Go back to the
yeah,
yeah,
that's
go back
what.
to the
Get
doc real quick. Yeah.
first. Get first. Let's see. So get the value in the alias by its key. If multiple values with the same key exist, only the first one. Oh, I see. So, okay. So it is basically checking for the
Oh,
first match. Yeah, yeah, yeah. Makes sense. Makes sense.
But it's returning an option. So why are we typing it as redeemer?
Oh, you're
it's
right.
returning an option. So why do we type it as a redeemer?
So
Yeah,
you know
yeah.
what
I
he's
get it.
saying? So he's saying what will end up is something like this,
Yeah.
you know, but they are directly enforcing the type redeemer. Yeah, these are the same questions I had like when I was going through this, but I don't know the answer to that still. Um, yeah, I don't know how they can directly assign the something to this and then enforce this type
Questions,
because this
questions.
will give this, right?
Yeah.
Some like what are we getting? Some redeemer.
Well, where do we use this? We pass it in to line 43 as the withdraw redeemer.
Yeah.
Okay, so that function, withdraw redeemer validator, is what? Is that expecting a sum?
Withdraw redeemer validator.
So let's look it up.
Is this a
Just highlight
function?
it.
Is this a
I think it's a
function?
function in this file.
I don't see it.
Well, look around.
Let
Oh, well, there it is. Wait a
else
minute.
do you look?
No, it's a type. It's a type. Look at that. Well,
Yeah,
no, that's
no,
not.
no, no. This is
Withdrawal,
a function.
redeemer, validator.
No, but I think this next 41 line should answer something, right? Because they're saying expect some withdraw amount. No, this
Oh,
has
it's
nothing
right
to do
there.
with.
Line 29. Line 29. So
Yeah,
this is like a special, everything's special today in this.
yeah, it's a passed-in
Oh,
function, right?
Yeah,
So
it's a function. Yeah.
look how it takes a redeemer. It doesn't take a an option. It takes a redeemer and Lovelace.
Yeah.
So
yeah.
withdraw redeemer is of type redeemer. It's not of type sum.
Yeah,
Or
I mean,
some
somewhere something
redeemer.
is missing. Like,
I think I think maybe it just forces it to be the value inside. I think it just unwraps it to the
oh,
redeemer. Yeah, but I'm not sure about
okay, interesting. So I wonder if we can like actually force stuff like
What
that.
is this
Like,
called? Is this called downcasting? There's like a couple terms on the docs.
Oh boy.
Yeah,
Yep.
I don't understand completely, but maybe this is it. I don't
Yeah.
know.
Look up
It'd be cool if,
downcasting.
yeah,
downcasting, soft casting is
We
there.
that's
The
not it.
expect key, huh? No, okay.
That's yeah.
Harsha and I
I'm
went through this and where it was like, and generally Harsha, just FYI, generally Harsha will want to dig down deep. And I think Code Cow maybe also a dig down deeper, but I'm like, do we really
Oh,
need to
I
go to
think
that
Code
right
Cow
now?
is like more of a make it work kind of guy.
Oh,
He
okay,
wants to
good.
make it
You're on
work.
my side. Yeah, Code
well,
Cow's
in
on my side
general,
then.
but this is my time to like stretch
To
this other
dive deep.
muscle.
Yes,
Yeah.
that's right. That's right. That's right. Yeah. Okay. So were you able to find it?
What am I looking for?
Yeah.
Like casting from
So
data.
soft casting and look in the language tour. Okay, so here's something about the Aiken docs. So click on the language tour. That has like the real brief,
Language
like
tour. Where
there.
is that?
That
Oh,
has
just like here?
yeah, just the headline. Anyway, so that's like the 5 minute tour. So look first there, and then if you don't look for it, then you can search. I do the whole search through the documentation in the search bar up there. Because if it's in the language tour short thing, then it's important. You got to know it. But if it's down in the other one, so now just
Oh,
use your
I didn't know we could backpass stuff. Okay, cool.
Yeah, I've
so
never
back.
used that one.
Yeah, neither have I. Uh,
I know it's in there. I was part of my preparation for the day down is to scan through all this stuff. And
downcasting from data is
here we
not
go.
guaranteed, but can be achieved with expect. But we didn't even use the expect. Oh, maybe serialized values can be implicitly upcast to data during calls. So they said let color is RGB. RGB is this serialize color. So it's a function that takes data and gives a byte array.
Hey, Jason,
Yeah.
no pressure, but have you come across upcast and downcast, and do you have an idea of it?
I think what I've seen is in Rust, sometimes when you have an option, you can always unwrap, and then the type inside the option will become the type that you return. So I'm guessing in Aiken, there's some automatic kind of unwrapping going on, like going from option value to value.
Oh,
So, does that make sense? That sort of makes sense to me.
yeah,
The
yeah,
That
yeah.
it just
concept
becomes
does,
the
but have you
yeah.
seen it anywhere in Aiken?
Not really.
No, possibly. Yeah, that's maybe that's the
Right?
way it works. Yeah.
I don't know. The concept to me makes sense. I'm unwrapping. I want to see where it says that in the docs of what's happening.
And yeah, how did Anastasia Labs know that?
Well,
Well,
yeah. I mean, if it's a thing, like I don't know. Then it's a trick that we can use all the time. And
yeah.
maybe it's just that. But I don't think that's it. I think we're missing something. Maybe it's this pairs. Maybe maybe the
Pairs,
get
what does
first
pairs have to
is
do with
not
it?
returning.
Oh, because it's a function in the pairs. Okay, okay.
Yeah, like I feel like that's what we're misunderstanding more than like we're unwrapping something special with that. Like I feel like pairs get first is returning the value. It's like
So
see how I don't know. That doesn't make sense. Oh
so I
well.
was able to find downcasting and upcasting.
Yeah, downcasting and upcasting are
They're in
in
custom types,
types.
custom types. And then, so here's all our typing stuff.
But that
And
doesn't
it's
do the
towards,
unwrapping Jason was talking about, right?
Yeah, yeah.
Yeah.
I genuinely don't know where to look, to be fair. Is there a word we can enforce?
just scroll all the way down. It's towards the bottom of the doc. Yeah, keep going, keep going, keep going. Should be in there somewhere now. Right there. Scroll up, up, up. Keep going up. With some pace, keep going up. I think that's the
with some
bottom of
pace.
it. There's downcasting, and then right above that is upcasting. You go up, you'll get the major heading is relationship with data. It's just right above that. Yeah.
This one, at
Yeah.
runtime, custom types become an opaque Plutus data. Plutus's data. In Aiken's type system, what is this? In Aiken's type system, data matches with any user identified type, but none with the primitive types. Okay. Thus, it is also possible to cast any custom type into data.
Let's pause there. Are we dealing with a custom type here? Aren't we?
Yes, we are dealing with a custom type because Redeemer
Okay.
is just data.
Yeah, yeah. Okay.
This implicit conversion is handy for interacting with built-in functions that operate on raw data. Any function that accepts data will automatically work with a custom type. But this is just saying like, hey, data can be of any type, right? Or am I getting this wrong?
No, I don't think this is what we were initially
This is not what we're talking about. Okay. Okay.
Can you scroll down a little bit more before we're here? Downcasting, go one more. Type aliases. What does this say?
Finally, it is also possible to define mere aliases for your types. A type alias lets you create a name that is identical to another type without any additional. This is just an alias.
Okay, so what is aliases are fully interchangeable and bear no difference at runtimes. Type person equals.
Yeah, this is aliases. Like we have seen a lot of aliases, right? Like for example, I can't remember right now, but we have seen a bunch of aliases, like for the byte arrays and stuff like that.
It's okay. I don't know. Yeah, I don't know what's going on. I would say if we want to figure it out, we would run tests and we would trace out both of the values and figure out what's actually being returned.
Yes,
and that's the way to know.
So this is a question to you, Mr. Don Harsha.
What?
You want to follow this thread down, or you feel like we've
how are you guys
feeling?
Enough? Do you want to jump into this and but where will we go with this thread? Because I feel like we hit a dead end some here, and I don't know where to go from here. I would rather go with the tests eventually, and then we can maybe figure this out.
You're done.
Yeah. You're the Don, buddy. And I think that's a good idea. We can kind of flag that as like, hey, this could be a really fun thing to test out, like what CodeCow is suggesting. Is like, okay, we could trace it and see what. Yeah, test.
It's type saying this is the okay.
Beautiful.
Okay, so we'll test it out. And then this line we have expect sum withdraw amount. Why is this sum? Because pairs.get first is sum. So wait, withdrawals is being piped into get first, and withdraw script is the key. I quickly want to take a look at withdrawals 1 second because I forgot. Oh, where is withdrawals? Oh, so it takes the credential and the Lovelace. Okay. So what are we doing? So we have credential and Lovelace in this pair,
Right.
and we are checking which script purpose, withdraw scripts. Oh, so that's the credential. So we are checking for the first match of the credential, and we get the amount of Lovelace. So withdraw amount is the amount of Lovelace, and since this gives option, they are using sum here, but somehow here this thing changed things. Okay. Yeah, so we get the withdraw amount here, and then withdraw redeemer validator.
That's our passed in function.
Oh yeah,
Yeah.
yeah, this is our passed in function. Oh, so this takes the redeemer and the amount of Lovelace and gives a bool. And this is a function that we can define, by the way. Right? That's how it works, no? This is a self-defined function because they
Yeah.
haven't
Yeah.
defined it.
What is that? I want to drill out on that. I just
I
came
think
into this.
I think it's good to look at the implementation now.
Okay.
Implement. Okay, so just try this out. So let's go to pot spend. So this is, oh shit. So this is Code Cow's implementation of what we just saw, not Westing Wizard, of this guy. So
Okay.
Code Cow wrote a type which is the pot redeemer, which has a constructor withdraw. Okay. So we have a redeemer type right there. And here they have created a validator called pot spend, which takes in the withdraw script hash. And the spend script purpose takes in the optional datum, takes in the redeemer, takes in the input and the transaction. This is standard parameters for the spend script purpose. And they say let withdraw is a type is equal to redeemer. Oh, so they're
So creating a
so it's
withdraw.
just this guy. So they're saying the redeemer is of the type withdraw.
It's like all of this is not important. The only thing that matters is this function,
Yeah.
right? This is the implementation. We're trying to figure out this function, right? Like, if we looked at the other one, we were saying, what is this function that we pass in? It's this. This is that function. So, like, I would just remove all of this because this is not what we're talking about. We're only talking about this, and it's this function, and you're saying, does the quantity equal 0?
Yeah.
This is the withdraw redeemer function. So it gets the script hash, which is parameterized, right? So it's all dependent on this script hash.
Mhm.
And that goes right here into the first value of this spend function, gets the script hash, and then it takes that function, which is only checking if quantity equals 0.
Yep.
Yeah.
And
Yeah.
then it's passing the transaction. So then if you go to pot withdraw, here is where the actual logic is going to happen, is inside of this. Maybe we're not at that point yet, but
this gives us a point of where we're going anyway.
Yeah.
So this stake validator is a pattern that you're using in these other two scripts,
So
these other two Aiken files.
Yeah, if you remember, we've been looking at the function called spend. If go back to stake validator.
Oh,
Harsha.
yeah.
Right, it's a function called spend, and then it takes, look at its parameters. It takes a withdraw script hash as the first one, and then it takes the withdraw redeemer validator is a function that returns a bool, and then it takes a transaction. Okay, so those are our three things we pass in. Now let's go to pot spend and see the implementation, where we do see how that's the parameterized script, but then stake validator dot spend, that dot spend, That's that function. Okay, you can name it
Yep.
whatever you wanted. That's just what I named it. And then here are three things that we're passing in: the withdraw script hash, which is the parameterized things from this validator, and then our function, which is only checking quantity equals 0, and then we pass our transaction.
Okay.
So tell me one thing. What's the point of this function? Oh, because it is a necessary parameter, right here, the redeemer, although you're not using it in your implementation.
We're
This
only
R-
checking, yeah, exactly. We're only
Quantity.
checking if quantity equals 0. And so the point is, this is a validator, right, Newman? This is an actual validator. So you would
Yeah.
send UTXOs here, and then you would try to spend those UTXOs using the first. Where am I? Let me get in. Right. This is a real validator. So you're going to lock UTXOs here, and then you're going to try to spend it.
Yep.
And when you're spending it, it has to run this logic. So there can be 100 UTXOs here. You're going to try to make one transaction and spend all 100 of them. In that transaction, you need to make sure that you're using a script hash with this withdraw from it of 0. So you're withdrawing the script rewards equal to 0 amount from this hash. And that triggers the logic of pot withdraw, which is where you would do any of the logic that you wanted to do on the UTXOs on the transaction.
Oh, so in this case, where's that? So uh one second. I just wanted to like go to this design.
Oh,
So here, I think from what Kodka explained, first the transaction goes to this script, which is the staking script, and if it gets validated in this script, then it is passed to the spending script, and not no.
No, getting stake rewards is
Mhm.
a special thing in Cardano. It doesn't even work with UTXOs, right? It's like a account-based model. But it's a special, it's a separate thing.
Mhm.
So
it's
when I'm in my
a
transaction and I'm doing my transaction things that we're used to, an additional thing that I can do is withdraw my staking rewards,
Correct.
which is basically saying like, hey, I've staked from the last 10 epochs or whatever, and things have accrued, and now I'm going to withdraw those. And that is a special operation I can take within a transaction.
Correct.
So that's what we're doing here, but we are parameterizing things in a way where that action of withdrawing my staking rewards, if it's 0, if those staking rewards are 0, then it like runs this logic.
This logic, as in the spending logic, right?
Yeah, it's whatever we want to hide. It's
It's a trick. This is a trick.
It's a trick. You're putting logic in the staking rewards claim, right? Like I'm owed staking rewards. I'm going to claim it during this special thing. And the trick is attaching logic into that.
Oh, I see.
And
So now I think I understand, but tell me, so this quantity is equal to 0. Instead of checking it for each input, you're checking all of it at once in this one, right?
Yeah, because who owns the staking rewards? It's like it's the public cache, it's the owner. It's not the inputs. It's the user that's making the transaction.
Correct.
And so whatever inputs they're trying to spend or whatever, it has nothing to do, like technically, right? It has nothing to do with their staking rewards. They're just withdrawing those rewards. They're able to do that. And the trick is tying it all together. I don't know.
Makes sense. How about the rest of you feeling? Is this making
That's-
sense? Can one of you explain to me, because my head is kind of like spinning a little bit.
So I am definitely, there's a part that's spinning, but Code Cow has definitely laid down a thing,
Yeah, for sure.
a beacon for me because then I'll go first, and then let's go to Lewis, and then Jason, and then hey, Emmanuel.
Emmanuel
Um,
raised a hand.
oh,
Hi guys.
go for it.
Oh,
Hey, go for it, Emmanuel.
Yeah, first apologies for not making it. I was thinking our class would be actually I couldn't still I won't still be able to make it till the time of the starting of the meeting. So yeah. Um in this Asha, you showed a validator earlier on that we parameterize the transaction. I don't know if that's actually what I saw. Can you, is there a validator where the parameterized maybe the argument is a transaction? I don't know if
yeah,
I saw something
this
like
is
that.
the one, right? This is the one you're talking about.
No, I mean, okay. Yes. No, not really. Like I mean the valid. Okay, this is it's a function. Okay, I was thinking maybe it's a validator because I was thinking, oh, you are parameterizing a validator with a transaction. How are you going to pass in the transaction to the validator? Something like that.
No, this is just a function. Like here, we're not parameterizing, say, for example, here, we're not parameterizing the validator with the transaction. The transaction is passed during the spend purpose.
Yeah. All right.
Yeah.
Yeah.
And you're just passing it since we have all four of these variables right here, you're passing these variables here. Like the
Yeah.
transaction you're passing here, and these two, and the script purpose, sorry, the script hash is from here, and this function is self-defined anyway.
Oh, okay. Um,
And uh, yeah, the this stake validator dot spend. Are we actually importing it or something?
Yeah. So we are actually getting this from this directly. We're importing it from the Anastasia Labs, which is right here.
Stake validator dot spend.
This is
How do you
Aiken.
put a validator inside another validator?
No, it's
Is
not a
that what you?
validator, it's a function. It's a function.
yeah,
Okay.
it's so
Right.
that's something important to be reminded. Like
Oh,
this,
This is a function that we are importing. See,
all right. Yeah.
we are importing this function into our validator.
All right.
and okay. Thanks for that, Emmanuel. But I do want to stick to this sort of around because I would like to hear from Lewis and Jason, and then I've also got something to
Did you
sort of
call Jason
add.
Jason? Okay.
Jason, yeah.
Are we
It's a
asking?
cool
Are you
name. It's a
asking
great one of the
on?
great names, one of the greatest names ever, I think, in my mind.
Are you asking on the stick validator spend?
Yeah, in general, the concept, is it getting a little bit clear for you, or is it still a bit fuzzy?
My head is on
Yeah,
fire, man.
nice. Put it out, man. No, don't put it out. Wait, no, uh, that's good enough. That's good enough. I mean, anything other than that, or is that it? Okay, Jason, what's next? How are you
So
feeling?
I think the concept is a bit fuzzy, no pun intended, but also clear. In the sense that, okay, so what I'm getting from this is that every time you want to spend something in a script that is locked in a script, you obviously provide a script hash and the redeemer and yeah, the other requirements. But then when you want to withdraw your own funds from a stake validator, you don't want to use the same script that you're currently running. So you can pass in an extra quote unquote script that helps you withdraw, let's say, rewards from somewhere. I'm not sure where that somewhere is at this point, but
Yeah.
so it's
Okay.
yeah.
So
Uh,
That's
the way, yeah. You want to?
It's this script hash that we're parameterizing. It's like it's the staking claim. I deserve these staking rewards from this script hash.
Oh, I see. So basically, you
Well,
are spending from this script, right? The script that is derived from this script hash, right?
You're not spending from it, you're withdrawing its staking rewards.
Oh, okay. Yeah.
which is a special. Remember, I'll break in here just to say that withdraw is a special validator purpose, and and it
Transaction.
takes in a transaction, a special transaction. And just for this is what I'm sort of getting from it. And again, remember, I'm of that type where like I just want to make it work. And so I'm like, okay, what's the first sort of like, how do I categorize this, or like where do I put it? And it seems like, and correct me if I'm wrong, it seems like it's a way to and I think maybe I saw this, like offload or to quickly fail or to check if some transaction can work, meaning if they are able to withdraw, even if they're withdrawing zero, then it's like a check. It's just like, can you withdraw zero? Yes, then you're the owner of this script, or etc. And then you can put more transaction logic, conceptually underneath that or behind that.
Yes.
And then
Oh, that's
in
a
a
really
way,
good way of putting it, Newman, because now it makes it clear, like what you just said. Okay. Yeah.
I learned it
So,
from Unspin. Unspin explained it that way, and I think I got it. Yeah.
just a
Yeah,
quick question. So does that mean that the original script is not checked? Because
it
it seems
is.
like it is.
Yeah, the withdraw. This is the one you're talking about, right? Because there are two scripts that work together. So in the spending
Right.
script, you're using this function, and in the withdraw script, there is other logic.
So you would need to first parameterize the pot withdraw, and get that policy ID and script hash, right? After applying the params to the CBOR, because then you're gonna parameterize pot spend with that. That withdraw script hash is it's the CBOR of pot withdraw. Does that make sense?
Yes.
All right.
Newman,
Okay.
does that make sense to you? I feel like that's a crucial point.
Yeah. So you're basically saying this is credential. The staking credential is pot withdraw's credential. Is that right?
Is that it's like when you get a CBOR of this validator, the pot withdraw, you parameterize pot spend with it.
Yeah, so this is the script hash, right? Like this is the pot withdraw script hash here.
Yes, exactly. Yeah.
Okay.
Sometimes we use hashes, and it's like I don't know. The terms sometimes confuse me. The way that I think about it is it's like I'm putting pot withdraw into pot spend. Like that's how I think of it, kind of. Like the result of pot withdraw on chain is like a CBOR, and I am putting that into pot spend. I don't know. Maybe I confused you.
No. I got it. Like how is everyone else feeling?
Well, before we go in, well, no, that's perfect. Yeah, let's. I feel pretty good about it. I feel pretty good about it. Would I be able to write a validator constellation, a group of validators using this? Possibly not, but I would be able to say, oh, this might be a place where I could use this withdraw script, debor, where I could use this trick. Or if I saw it, I might say, oh, they're doing that trick. So that's my
I think you could
response.
implement it easier than it's understandable.
Yeah.
Right? It's really simple because it's like if I want to do things here, do things with logic on every UTXO in a transaction. Okay, and whatever, you just write all your logic and you can do it here. And like, it's exactly how you expect it. If you want to do the trick, you take all of that logic, right? This is our new logic that we just wrote out here. And instead we just paste this here. I'm going to copy my logic. I'm going to
and just put it in this function, right? Your logic is just in the function? No? Okay.
No, this function is checking the quantity. It needs to make a withdraw of 0 from this script hash. And then all of that logic, we go into pot withdraw. Come here, Harsha, follow me into pot withdraw.
Yes.
All of that logic goes right here.
Okay.
That you would have written in pot spend.
Yeah.
So everything else is boilerplate around it. This is boilerplate around it. You just copy and paste. This is boilerplate around it. You just copy and paste. All of your logic you originally had in pot spend, just put it here. And in pot spend, come back with me, Harsha.
In pot spend. Okay.
In pot spend, all of that logic that you originally wrote here, you deleted, and you just added this. A quantity of 0 with this script hash. And you're good. You've implemented it 100%. You don't need to understand anymore. It's like, just write your logic like you normally would in your pot in whatever validator you're doing, and then make an additional validator called withdraw. Get the script hash from that new one, do a quantity of 0, and then put all the new logic in pot withdraw. I don't know. I'm sorry. I tried.
No. I think that makes sense.
Kind of makes
never
sense.
apologize. The great ones never apologize. Hey, Lewis, what do you think? Lewis, what do you think?
I was just following Code Cow's explanation. It kind of makes sense to me. So I need to piece it together.
Yeah. Jason, what do you think?
Yeah, I think it's much clearer because so now understand that what you're doing is you're reducing the amount of computations you're doing. So instead of doing the so in pot spend, instead of, because pot spend will go through every, I think, output, and then do some logic and then say if it's false or not, and then but then here you, instead of doing that, you just do it for this quantity is equals to 0, so this will always return true, and then if the quantity is 0, and then so that will happen for everything. So you only do it once, and then the logic will be done in the script hash that you pass in. So
yeah, that makes sense to
Beautiful. Absolutely. Emmanuel, I know that you came in a little bit late, but are you able to sort of pick up this thread?
Yeah, the fact that I think this is my first time, not really first time, but getting familiar with a withdraw validator purpose. But I'm just curious. Is it like how is this? What is the purpose of the withdraw validator? Like how is it implemented by a stake pool operator? Whoever wants to make this validation work.
By the stake pool operator, like who is here? Is there anyone that's a stake pool operator? Jonathan, I think you have a stake pool. Do you guys implement this in any way?
Hi everyone.
Hey.
Whoa, all right. Yay, we're partying now. What's happening?
It's been a long time. I'm good, thank you.
Thanks, man.
Yeah, I have stake pool, but no, I don't do this.
All right.
I think this is just like a validator that uses the withdraw. It's not necessary for stake pools, I think.
Then what's differentiating it from spend? If it's just to withdraw from, I don't know what.
Oh, so what is differentiating it from spent? Okay, I think unspent, like mentioned this. This is a special kind of validator where I think they don't use like a UTXO model. They use a what is it called? Account book model. Is that what you said? Unspent?
Oh,
Yeah, that's not an important part of it though. But yes.
Yeah. So that's where my understanding ends.
It's so
yeah.
right, it's a different purpose. Obviously, we're looking at withdraw. The other
Yeah.
purposes are mint or spend. Right, and there's a couple other ones. So that's kind of the first thing to note is this is a withdraw purpose.
Mm-hmm. Yeah.
It's 15 hours.
Hey, it is 15 hours somewhere in the world. It's 10 hours where I am, but where you are is with the community code review, the Datum Dons, presented by Gimbalabs. And this is where we explore Aiken code together, line by line, question by question. Hey, if you're watching this on YouTube and thinking, I got questions too. I want to hang out with Jonathan, Emmanuel, Jason, and hey, why don't you come and join us live? We do this on Thursdays. You can hop in as a capo and ask questions and challenge ideas and learn right alongside of us. But after a while, you can become a Don and you can hang out with us. It's a really incredible open source learning, and there's always room at the table. That is the station identification. Proceed as you were.
Jesus, like you just became a bot, Newman. Like I was
Well, I realized that we would normally just do that. We would normally just do that as like a bumper. You know, we would just slice it in, but we do it live. We do it live here because we're live, man. We are live.
I've never gotten used to that.
I imagine us chilling eating pizza together, and somebody plays like a little thing on their phone, and then Newman just goes off out on this tangent.
I
It
do
was like
like
an
doing it,
ad,
man.
an
I
ad
could be a bot.
mid-session.
I could be a bot. I could be a bot. I'm just throwing that out there as, you know, as a thing. All right.
Okay, so I think we all kind of understand what's going on with the whole thing where we are basically using a trick to reduce the amount of compute, where the spend you have to do the compute for each UTXO, but with the withdraw you can do it in like one swipe. So that's what I understand. So what do you guys want to do next? Do you guys want to test something? Like how do we do this?
The last thing I want to say real quick is if you go back to pot spend, we've talked a lot about how we're offloading logic, right?
Yes.
Well, here we still have logic. Every single UTXO is checking, do we have a withdraw script hash of a quantity of 0?
So that's run on every UTXO.
Wait,
Yeah.
what do you mean every UTXO withdraw script hash? Like
What
the
we're looking
withdraw
at
script hash
here,
is a transaction thing, not a UTXO thing, right?
yeah, but every UTXO, like this validator, right? In order to spend from this validator, it needs to run this function. And so the idea is it's less logic to just check this function equals quantity is 0, and then
Correct.
all of the actual logic is hidden underneath that. But it's important to note that like every UTXO is still validating this. It's only this part.
Oh, I see.
Only this. Yeah. I have a super simple question.
Okay. Yeah. Go ahead.
All right. So my super simple question, which is like basic 101 Aiken, even just modern, whatever language. So how does it know? Like I know that spend was identified or I don't know what the language word is for it, but if you go over to stake validator, AK Harsha. So that's a public function in line 27.
Yeah.
It says pub there. does that, do we have to import it basically? We don't import it in Potspin. Does
No,
it
no, we
just
do
know
import
that
it.
it's,
We do import it. We have, I
oh,
mean, like currently we don't have the imports, but yes, we do have to import it in this.
okay. That's all it's just, so we just copy, we just are looking at the snippet. Okay.
Yeah, we
That's
actually
all I
import
wanted.
it from this file into our pot spend
Yeah.
and then use the function. Yeah.
Okay.
Okay.
That's all I was saying. I was like, it just looks weird. Like, what, how does that even, okay. If
Yeah.
you're following along at home, that's why that looks weird. Okay.
Yeah. Jonathan, I know that you write some code, so I'm going to ask you this question. This is where we were stuck a little bit. So here we have a withdraw redeemer of the type redeemer, and this function get first gives an optional type
Oh,
as a result. Get first. It gives an option value, uh, and this is of the type redeemer. So is the redeemer somehow forced to like bypass the option? Oh shit, what happened? Something happened.
you're following somebody now. You,
Oh, really?
yeah.
Oh,
Jason focused your attention.
Wait, what did I do?
no,
Oh,
nothing.
I think Harsha accidentally started following you, and then when you clicked somewhere, it jumped over to where you were. But I think it's fixed now.
So I just don't understand how this redeemer type enforces. Is there something that's happening where this type somehow like bypasses the option that comes out of this function? You know?
Yeah, I don't know. I'm not familiar with Aiken at
Yeah.
all yet. I'm here to learn.
Oh, do you write in
Oh,
Haskell or something or Plutus or something?
So I've done the Haskell Academy course.
Oh, I
But
see, I
yeah,
see.
in regarding smart contracts, I'm complete novice. I
oh,
code application like web apps traditionally, typically.
So
okay.
Yeah.
you're more like
You're in the
Code
right
Cow.
spot.
Yeah, Code Cow
You're
was
in the
also
right
like
exact
a
spot.
developer.
Yeah.
Yeah.
And I do a
Okay,
lot
then
of
we've
sysadmin stuff and DevOps stuff. So yeah.
Oh, nice.
Yeah. Mm.
hey, so
But this is
Harsha, so when the in the next 25 minutes or so that we've got in our 90-minute slot,
Mm-hmm. Mm-hmm.
do you want to, as a Don, you can drive us wherever, but this might be a fun way to test. And
Mm-hmm.
and I do think it would be a challenge to try to run some mocktail like test out and
So
see.
just like run tests in on this, like, yeah, we can run tests on
I
this.
mean, if you feel up to the challenge of like writing some tests on the fly,
No, it
um,
already has tests.
what?
Yeah, let me just comment these guys out. But Stake Validator already has tests. See?
Oh, you're right. Check that out. So this is one of my favorite things. And it
So all
is
tests
sort of
passed. Okay.
okay, let's break.
So if you want to take
Let's
a
look.
look at the tests, or do you guys want to check the other functions because there are a bunch of other smaller functions they provided as well. There are two more functions. There's a
Unspent.
spend
What do you think?
minimal and there's a withdraw, which is like what CodeCow was mentioning. What do you guys think? Do you want to take a quick look or do you guys want to jump into the tests or?
Yeah. Anybody got an opinion or where they want to drive it? Hmm? Hmm? Go on. It's up to you then, Harsha.
I
Take
mean,
us where you
so
feel
let's
most
let's
comfortable.
do this. Let's at least go through the spend test because this is the function that we have already gone through.
Perfect. Absolutely.
Okay.
So let's review it. Let's look and understand this test really quick.
Yeah. So this is a function. This is a success spend function, which is also a test, and it takes the parameter script hash via fuzz. So this means this this gives like a random byte array,
Yeah.
fixed byte array of 25. So, is there anyone that knows what a fuzz is? Because as far as I understand, fuzzers are basically random. There is nothing called random numbers in the blockchain because it's deterministic. But this is a way to introduce like some randomness into the logic, is what I understand. Does anyone know? Do you know, Code Cow, like about the fuzz?
Sorry, I was focusing on work for a second. I'm back with you now.
Oh man. Oh man.
I know. I'm sorry. I'm sorry.
It's all good. It's all good. Let's
So what
look
was
at
the
the
question?
docs really.
Yeah,
Yeah.
Do you know anything about the fuzz and how it introduces randomness into the blockchain?
No, there's a lot in the docs about it. There's many functions for it. All I know is a lot of the examples I found open source use previous versions of it, and it seems to have changed. So every time I see fuzz, I'm always a little worried.
So at least for
Where?
this specific line, at least, it is saying we are getting a random byte array which is of the length 28.
Okay.
And that would be used as the script hash.
So we would normally do like a mocktail or cocktail thing for that. And
Do we have a mocktail thing for script hashes?
yeah, mock script
Yeah, we got it.
hash.
Of course. Yeah. So we could just change that test and just
Oh,
use
this is
our
vodka.
super awesome mocktail.
Yeah.
Yeah, mock
Script
script. Yeah,
hash.
yeah.
Yes, let's do it, man.
Maybe they also use fuzzers. Let's see their code.
Oh,
Virgin key hash dot mock script hash.
You got to click around. They
yeah. Go to
export.
version key hash.
Click around as
No.
in like
Go.
here. No.
No.
I would
Back
say go to
to.
Don's docs because I already.
Oh,
figured
you're
that
right.
out.
You're right. Fuzz.
No.
And now you can sort by the packages.
So design fuzzer. And
Right,
this
if you
is
just want
input.
Just go to vodka. No. Mock.
Yeah.
Do you have the
Go
mocktail?
listen, Harsha, move your mouse forward up top, vodka. See on the from packet. I want to see from. I want to see.
Yeah.
No, the vodka you said?
No.
Oh.
In the middle of the screen, see that from section? There's buttons, all sources.
Yeah.
Click vodka.
From vodka. Okay.
From vodka. Okay, now type in whatever that function was. Mock
Virgin
public hash.
something.
Mock script hash.
Yeah.
Here we go.
And by the way,
Docs
this is
going
the
out.
Don's docs is like a unified docs which has like Aiken, Vodka, and Anastasia Labs stuff all together in one place, and this is designed by Code Cow, by the way. Okay. So mock script hash, it is a function that takes a variation of an integer and gives out a script hash. So mock key hash variation plus 2000. What the fuck is 2000? Is it mock script hash?
Hey, let me break in right here. What I'm looking at is that we don't see any mocktail. So those vodka. So those three are all in the. Oh, wait a minute.
Mocktail is right here, no?
Script hash. Okay, no. All right, yeah.
So, and then you can also change the grid if you want on display options, and you can make that bigger.
Oh, where?
On the far right, display options, grid toggle, the grid 4.
One second. Display options. Where is display options? Oh, right here.
Right there.
Grid.
Harsha always has a hard time finding things, man.
Yeah, I really do.
Yeah. Well, I will tell you that is why Harsha is getting extra cash for this meeting, because he being in the hot seat, like it takes
Yeah,
off intelligence points. I mean, it really is. And so let's be gentle on Harsha,
Yeah,
because
I
we
have
all
like
are
3
not in the hot
intelligence
spot.
points and like
Whoa,
now it's
I
just 1.
apologize. I was just
No,
joking.
no, Lewis, you can do whatever you want, but like it is true that, I mean, yeah. And Harsha's got intelligence to spend, that's for sure. But yeah. Okay. But I think we're good now.
Yeah. So yeah, they're directly using mock key hash. But
so I
I
would
feel
search
like,
for that.
yeah, now I feel like they have to use functions, fuzzers somewhere, mock key hash. Do you already have this mock key hash
Yeah,
here?
it should be all there. I like literally just ingest the docs.
Everything. Yeah, there we go.
Mock
Enter.
key hash. Serialized variation, and it is piped into concat root hash, and that is piped into like a hashing script.
So they don't use fuzzers. I guess
They
all this
don't, yeah,
computer
they didn't
answers,
use
like they
fuzzers
don't use
here.
them. Okay.
So
So let's just sub out, like let's just skip
Well, what does
fuzzers and
serialize do? Does serialize
yeah,
use a
I
fuzzer?
want
oh,
yeah,
true,
let's see. I
true.
don't, where do you even get this from? Serialize.
Now
So
copy
I
that,
would.
paste it up there.
I'll
You're gonna
just
have to do all sources from all sources.
okay, all sources. Yeah, so
Well, you got to search more because there's some different. That's from Anastasia. Oh no, yeah, it is.
no,
That's
serialize.
serialized key. We just want serialized.
Is there
You
like
may
a
have to
function like
do standard library from standard library,
okay.
right? Or prelude if it's from there.
Let's see. Not from Prelude. It's only in Anastasia.
And then, okay, so here I would do on the display options, toggle show code and show imports. And now you can see everything.
I see,
man.
I see. Yeah, we don't have a serialized function. I think it is coming from where
I thought we did. Maybe you have it spelled wrong.
oh really?
I don't know. I thought we did. I just do SER. Just do SER.
Ooh, look at all
And
that.
then,
oh, there's a serial. Oh, LISC. Okay.
Oh man.
Now
Okay,
I
so
want to
now
see.
show the code. And it's right there.
Yeah.
okay, see, and now you're starting to understand why and how it maybe can help us.
Yeah.
Jump around, see different things.
Harsha was like, no, I like doing it my own way, which was harder, but but he's figuring it. We're figuring it out.
Yeah. It takes some data and gives a byte array. And now we'll have to see serialized data because every function is
But the point is they're all here. And
yeah.
like, because before we would be jumping from vodka to standard library to the other thing. And like here, it's like you can just kind of keep tracing them. But until you get there, because what the hell is that? Fail? It returns a byte array fail?
What is this? Like, I don't get it.
Pub function. I don't know.
Maybe it's work in progress. When you were just when we were just searching for serialize with the SE, there was a fuzzer function that came up underneath the serialize one.
Ooh, that's what we wanted.
SE.
That's what it looked like. Just scroll down. I'm sure I just saw it. User output fuzzer, user input fuzzer.
Oh, Jesus, how did you find that? Where is this?
Oh wow! Now we know Jonathan's superpower. He's got crazy good
like
eyes.
he
he
can just
there
like find stuff in like heaps.
It's like 8 down. Don't
8 down. You said 1, 2.
Up. No. Yeah, right in there.
Wait, what are you saying? Like, what are you looking
Go
at?
down, go down,
Seven
down, down. I'm
lines
gonna do
down.
Oh,
getting
7 lines.
cold. It
1,
get
2,
warmer,
3,
warmer,
4, 5,
warmer.
6, 7.
You're there. You're there.
Six.
Okay.
Six.
Yeah,
There.
yeah, yeah. Use output fuzzer. Let's see this function. And let's look at this. Use output function gives a fuzzer output. Okay.
This is from Anastasia, by the way.
Yeah.
Yeah.
So the reverse arrow. I don't know what the reverse arrow does.
Hey, look at line 17. It gives you the explanation.
Simple wallet UTXO fuzzer with a random number of tokens / NFTs. So is it giving? It is giving an output of the
Listen,
type fuzzer.
I
Okay.
think the original question was, is Mocktail using fuzzers?
Yes.
And I think the answer so far is no, but clearly
No?
Anastasia likes using them.
Yes.
Yeah.
Oh, okay. So we did find something out. You know, it is like a bit like driving a car with like several people at the wheel. It is it makes it fun because we're not crashing into anything, and I hope that everybody has sort of blocked off this time. We do have about 10 minutes left in our 90-minute thing. We can go over a little bit, but we definitely want to be respectful of time and all that.
Interesting.
I didn't go full bot. I just went like partial bot on that one.
Yeah. Yeah, fuzzer. So yeah, fuzzers from what I understand is like, say they introduce randomness, and that's where my understanding is. Yeah.
And then there's also a PNRG, a pseudo
PRNG.
random number. Yeah.
PRN. Yeah.
And yeah, my understanding ends with, I think where yours does too, is these are just these help us introduce random numbers. And personally, like I haven't come across using them.
Outside of testing, right? Like, because we are using mocktail functions, so they are introducing some form of like randomness anyway.
However they're doing it, we didn't figure that out, but however they are generating that.
Yeah. Makes sense. Where are we? So
what were we gonna?
Oh, we were doing the testing. I completely forgot about that. Okay. Yeah. That's fine.
Yeah, so that test between 73 and 80 or 81. And you could use a different we could use a mocktail if you wanted, or just keep it with this.
Yeah, I mean, we could use a
fuzz.
mocktail or this fuzz. So I guess both of them are doing the same thing. Since this is a byte array anyway, random fuzzer is fine. So they gave
basically
yeah. So this is this part, this random fuzz thing is this, right? Withdraw script hash is what the random thing is.
Yes.
Okay, so they gave a withdraw script hash, and then they're building a transaction. They have the placeholder, but they're changing the redeemer and withdrawals section. So they are creating a list with one pair. Pair withdraw the script hash. So this is the script, and this whole thing is the withdraw script purpose. That's how they build it. And built in I_data 0. Built in, so I'm guessing built in. Oh, I can check for it.
I would look up. Okay.
No, what were you looking at? How come
I would look
built in here? Yeah.
It's Prelude.
Oh, Prelude is built in. Okay.
Keep going.
What were we looking for? Wait, I forgot what we were looking for.
I would check up there in the redeemer type of the spend.
What was it? Redeemer type.
I don't know. I'm just talking.
Redeemer type is user defined.
Yeah, that's what I'm saying. Like, it's taking in that spend function. Spend purpose. Yeah, I don't know. Maybe I'm lost.
Yeah, so this is the redeemer, right? So redeemer has the script purpose, and the amount you're withdrawing.
Yeah. So
Yeah.
wait a minute, I've got access here.
So iData. So I was just looking at what iData is. iData is a function that takes an integer and gives a random data. This fail thing it doesn't seem like in process of building. It seems like a legitimate function that they're using in multiple places.
I don't understand that one. I think, do the regular docs end there?
Let me actually check iData.
So yeah, this has come from Prelude or built-ins.
Built-in iData. We can check here. Yeah, it's exactly that.
That's just I am parsing all of that.
So they're
it's
saying
just not
constructed
helpful.
data from an integer.
Okay, so
so
that means that, yeah. So that means you can get a data type. Oh my God. So if you need several different data types, you can just pass in a different integer, like inside of something. So this
what do you
just
mean
creates
data types? No. This data is not data type. This is data. Like
that's not.
That's type.
That's a type. It's this iData takes in an integer. I'm just reading this.
Yeah,
this
you're right.
iData function takes in an integer and returns something that is data.
Yeah.
Is that the way you understand it?
Yeah, it just like gives you like some random data. Just throw an integer, it gives you some random data.
No, I don't think it's a random generator. I think it's turning 0 from a type of int into
data. Yeah, that's what I'm saying.
Yeah.
So random data as in like, it's a random integer, so it's random data.
A past
so why don't they?
Yeah. So this is Lovelace, by the way. So you're changing some random integer, which is Lovelace, say 1 million or whatever, into the type data so that you can pass into the pair.
I just don't like how you're saying random because it's clearly 0.
Okay, it is 0.
Yeah. Okay.
Yeah.
Okay. All right.
And withdrawals, it's also a pair. You have the script. Oh shit. What did I do?
Was I wrong there? Am I misunderstanding how that works?
No, you're right. It just converts like an integer into the type data.
Okay.
Yeah.
Withdrawals is the script.
Oh.
Yeah. What were you saying?
No, I'm just me and Lewis are over here just sitting with our brains on fire. It's so much easier when it's us magpies on the poll as opposed to having a teacher here. And I do know that like Unspent, and actually it feels like Jason is also like, of the educator class or like they have a lot more experience, but it just feels more brotherly. And even there's the teachers are brotherly in Gimbalabs, but it's just I don't know. It's just there's a different vibe, and I love it.
Newman decided to be violent today and insult.
It's not an insult. It's beautiful, but I like having this. It just feels like our. I don't know what the mafioso. It feels like we're in our own little Italian Italian bodega, and we're in the back playing cards, and as opposed to, at some other more formalized function. Yeah.
Petition
anyway,
to carry it forward.
Yes, that's right. All right.
Yeah, so we just built the transaction here. I keep forgetting what withdraw does. 1 second. Standard library transaction. Withdraw is, it's a credential and Lovelace. Oh, so this is the Lovelace. Well, what is Redeemer?
So,
script purpose and Redeemer is just data. Okay. Got it. Oh, so they just
purpose.
Yeah, so I think they just like threw a random number which is 0 here, and they just
don't say
like
random.
No, but 0 is just like a random number.
Right. It doesn't actually. The specific one would be the withdraw 0, correct? Is that what you're saying, Harsha?
Yeah. This is what I got confused for this.
What is the redeemers even doing? Yeah, like why do
Yeah.
we even need that redeemer?
So redeemer is just data, so it could be anything, is what I understand, or maybe
Try changing it
because
then. Make it random.
yeah, make it like some 5, and
Okay,
let's
now
see.
run the
Good
test
choice.
again. Let's run the test again. Now this we get down to the good part. You know, it's like I'm just a kid waiting for something to explode.
This is a random
And
number. Like you can throw
it
anything in
pays.
here.
It passes. It passes. All right,
Yeah.
cool.
So it
Now-
doesn't
yeah.
actually care for the redeemer particularly.
But for my own sanity, why don't you try making the next one a 5? The other
this
zero
will.
5.
Do
So
it.
this is the amount of Lovelace, right? Are
Yeah,
they
it
even
should fail.
checking the amount of Lovelace in the
Yeah,
original
it needs to
function?
be 0.
But where are they saying it
Okay.
needs to be 0?
As a part of the whole, like,
No, we did that 0 thing in like code cows implementation, but here they're not even saying like 0 anywhere. It could be anything, right? Because
Are
they
you
did.
sure? It's because
They're
it's
just
called
saying
the
true.
withdraw 0 trick.
Wait a minute. Now let's have a little round. What do you think, Jason?
They just put in true, like in the send function in the test. They just
Go
pass
back
in
down to the
true. It's just true. Like it always go. Like it's always
It'll
true.
always go through. Okay.
Like line 80.
Yep. Oh, so okay. They say it's an always true function. Yeah, so they are basically defined. So you defined the function code cow as like the quantity is 0. So, but in here they didn't do that. They're just like saying true. We don't care because underscore quantity is what they gave.
Okay. Yep. Okay. Cool. Yep.
So if we change that,
Yeah, if we
withdraw
change
to
this
5,
to 5, it'll still pass.
it'll still go. It's not gonna be it's gonna be unchanged because
you're actually you're saying there is 5 ADA rewards there, and I'm gonna take all of those.
Yes.
And so, okay, for some reason I just made sure that was 0. I think because
no, in your case, 0 makes sense actually.
It needs to be 0.
Yeah.
Yeah. Okay.
Could you do that? Like put
what
equals to 0 and then save log.
Could you repeat that? What was that?
Oh, so could you do the quantity equals 0 in this test and then see what happens?
Yeah, this one right here, quantity.
No, the
in this one
80 line 80.
Line
no,
80.
Line 80. Yeah.
So we are
The
not
quantity
passing
0.
the quantity here. We are not passing the quantity here. If we do
but
this, yeah, but we are not passing the quantity. If we it is all depending on. Oh no, we will. Oh, that's what you're saying.
Jason, this is when you get into the live share and you just write the code instead of.
This is what Jason is saying, right?
Just do this. No.
Oh yeah,
doing
we'll have to remove this. No, you can't change that to 0. You can't change.
Why not?
Just keep it as quantity.
I just did.
No. So just take the underscore out.
Oh, okay.
Now
okay, I see what you did.
And if I change this to 5 now, I think it'll fail. Yeah.
Oh.
Yeah. Oh, and then what? Oh, what's the?
Not make it work. Do it to 0.
Wait, what was that?
Put it to 0 again and make it work because you also had other
yes,
changes.
You're right. You're right. Yeah.
Yeah.
Makes sense. Okay. I feel pretty good. I mean, I don't know how you guys feel.
We did it. Okay, I am not going to do the bot, but I do want to thank everybody for coming. Let's turn off the recording and have like a checkout round, and we'll kind of do all that whatnot. So, hey, if you're listening to the recording, you made it this far. Hey, why don't you come down to Gimbalabs, join our Discord? We all have fun like this every day, and it's wonderful. I really appreciate everybody for coming. Thank you so much.